Hi guys, so today we are looking at circles. So here we've got our circle, obviously. The line that runs across the center is called the diameter, and then the line that runs from the center of the circle to the circumference is called the radius. Now the circumference is kind of like the perimeter of the circle. It's the length of the outside edge, I guess. So something to note is that the diameter is 2 times the length of the radius. So it's exactly halfway because it goes from the center. Now the diameter cuts through the center and the radius goes from the center to the edge. So it's 2 lots of r, which is the radius. Or the radius is half of the diameter. So for our circumference of a circle, it's pi times the diameter, or pi times 2 times r. Now it's 2 times r because the diameter is 2 times the radius, which is 2 pi r. Where pi is the number that goes on forever, okay? That symbol represents literally that number. The area is pi r squared, so pi times the radius squared. And then I've got a funny joke for you, just because I know you guys are missing me. But there's something that I have always remembered for circles, and it's this little song, and you can like it or not, I don't really care, but it will help you remember it. So it goes, pi r squared sounds like area to me. If you want the circumference, you just use pi d, right? So it's pi r squared is area, and pi times d is the circumference. Or you can use 2 pi r, doesn't matter. So for example, here we've got a circle. It's got a diameter of 20. This means that the radius is 10. So the circumference is pi times the diameter. So pi times 20. Now, in exact form, we would say the circumference is 20 pi meters squared, because that pi is an irrational number, which means it goes on forever. But if you have to do it to 2 decimal places, you just literally press the pi button on your calculator, and you get 62.83. The area is pi r squared. The r represents the radius, so that's going to be 10. And then we've got pi times the radius squared. In exact form, it's 100 pi, or to 2 decimal places, you just literally put it into your calculator. Okay, so sectors. A sector is a fraction of a circle. So here we've got our fraction of a circle. It looks a little bit off-center, actually. This is a sector where we've still got the radius, is that length there. And this angle in the middle, this symbol stands for theta, and that's representing an angle in the middle of that circle. Now, because we haven't got the whole circumference, it's just called an arc length, because that section isn't the whole circumference. Now, because we're talking about fractions of a circle, the arc length, or that length of that sector, is given by whatever the fraction is of our angle. So let's just say this is, say, 30 degrees. Then we've got 30 degrees out of a total of 360 of our circle, because the whole way around is 360. And then you multiply it by whatever the circumference was. Like if you had a quarter, let's just say you had 90 out of 360, you've got a quarter of a circle, which means you'd have a quarter of whatever the circumference is of that circle. And we've got the circumference being 2 pi r, if that makes sense. Same with the area. You've got some fraction of a circle. Again, if that was 90 degrees, you'd have 90 out of 360, which is a quarter, and you would have a quarter of whatever the area is of the whole circle, which is pi r squared. So the examples: find the perimeter and area of the shape, correct to 1 decimal place. So as you can see here, we have a quarter, right? This 90 degree symbol represents 90 out of 360, which is a quarter. So for the perimeter of this shape, we need the arc length, and then these 2 sides are the radius. So we've got 3 and 3, because imagine that circle continued the whole way around, and we've only got the quarter. So for the arc length, remember, it's this section is 90 out of the 360 times 2 pi r. So 2 times pi times the radius, which is 3. That gives us this number here. If you're using it to 1 decimal place, when you work out this answer, keep it in your calculator, and then we want to add, so that's this section here, we want to add 3 and 3. So if you keep that answer in your calculator and add 3 plus 3, you'll get the exact answer instead of an approximation. So then that should give you 10.7. Again, with the area, we've got 90 degrees out of the total 360 times pi r squared, where r is 3, and that will give you 7.1 meters squared. Now, the last example, we're trying to find the area of the annulus. So an annulus is a donut-shaped shape where you've got the bigger circle and a smaller circle on the inside. Now, the area that we're finding is just this highlighted section. So to find that highlighted section, imagine you've got the area of the larger circle and then you want to take away the area of the smaller circle. So the larger circle, they're both pi r squared, but for this one, the larger circle, the radius, the r, is only 15 because the diameter is 30. So the r is 15, and then we're going to minus the area of the smaller circle, so pi r squared, where the r is going to be 6 because that radius is 12. The diameter is 12. You just halve it. Putting that into your calculator, again, if you want to 1 decimal place, you literally just put that straight into your calculator by pressing the pi button, or you can keep it as exact by finding out what that is and that is. And then you can keep it as exact. Let's just say, let's just say for sake that was 300 pi minus 36 pi. Then the answer is going to be 264 pi. That's the exact answer. Obviously, that's not 300, but you know what I mean. Okay, that's all. Good luck.